So now let's use our Newton's second law expression that when our post is in equilibrium, it means that the sum of the torques is 0. So our torques, as we have listed in our table, all have to add up to give us 0. And as we write it, we include the plus and minus signs. Okay, so all those guys have to add up to be 0. Let's see if we can figure out what some of these numbers are. So if we look, we see that t is the only thing we don't know, and we can figure out the rest of the numbers. So let's just make a note of what we know. The length of the post is 2.5 meters. That's what's going to go in for L. 2.5 meters here. Mass of the sign is given as 5 kilograms. And mass of the post itself, the post has mass 10 kilograms. So let's find the size of each of these numbers. Let's get those multiplied out. So our first one is L times sine 30. 2.5 times sine 30 gives us 1.25, and then that's times t, and the units there are meters, minus. So our next one is 2 meters times mass of the sign times 9.81. Gives us 98.1. The units here, mass times gravity, gives us newtons. This one is a meter, so we have newtons times meters. Then our next term, we have 1.25 times the mass of the post, 10 times gravity, 9.81, to get minus 122.6 newtons times meters. So there's each of our torques right there. Those are going to sum to give us 0. So now we can start to solve it. So then our tension, we'll bring these terms to the other side. So plus 98.1 newtons meters, plus 122.6 newtons meters. So I take this to this side, becomes positive. This to this side becomes positive. And then to solve, I have 1.25 t on this side, so I have to divide both sides by 1.25 meters. Let's see what we get for our tension here. So 98.1 plus 122.6. Divide that by 1.25, and we get a tension force of 176.6 newtons. And the direction of that tension force would be along the wire, or 30 degrees above the post itself. So there's our tension force. We're not finished yet because we're also asked for the force due to the bolt at the wall, so we have to find these forces. So what we'll do to figure that part out is next we'll go to the fact that the sum of the forces have to be 0.